So now I'm going to answer the question regarding the presentation. So first of all, what is the problem addressed in this paper? And the problem is to achieve a more efficient data center computing. So is this an important problem? Yes, because data center consume 3% of the total electricity in 2016, and this consumption will double every 4 years. Did the author motivate convincing this problem? Yes, the author tried to achieve lower energy per request, which reduce overall data center energy consumption. And this is a practical problem. So are there any solution out there for this problem? Yes, FPGAs and GPU net. So what's wrong with this solution, or why aren't they sufficient? And first of all is FPGA. Why this does not sufficient is because that FPGA has long reconfiguration time and it is not flexible. And for GPU net, it targets on InfiniBand hardware and traditional application. And in data center, we focus on commodity hardware and non-traditional applications. So the similarity and difference between the work and existing solution. So GNOM is similar to GPUNet, is to improve the support for application required network I/O on GPU accelerators. So what is the novel contribution proposed in this paper? So obviously it's GNOM software and the memory cache GPU. So is this a significant contribution? Yes, because it maintains the high throughput and low latency while using relatively low energy per request. And it is incremental paper because it is based on author's previous work. So how did the author demonstrate that their solution works? So first of all is the theoretical analysis. For example, the GPU Direct, which bypass the CPU and sends the IX packets directly to the GPU memory. And then the authors use the prototype implementation, for example, GNOM software and memory cached GPU. And the simulations on a single memory cache server and client directly connect using two Ethernet cables. After that, the author compares the GNOM and memory cache GPU's results with the control group. So did they demonstrate this many times or just one or two times? So for example, when the authors are evaluating the throughput, they averaging over 3 runs to improve the reliability of their data. So did the author achieve what they set out to do? Yes. Using GNOM and memory cache GPU, they are able to achieve 10 gigabit line rate processing at all request size and using only 16.1 μJ of energy per request while maintaining 1.1 millisecond low latency on a high performance NVIDIA GPU. So is the paper well organized and presented? Yes, the author first point out the problem of data center energy efficiency, then introduce some background knowledge regarding this paper, and then introduce the GNOM software architecture and the design of memory cache GPU. The paper then evaluated the proposed solution and compare with the relating works, and finally present a conclusion of potential to exploit the efficient parallelism of GPU for network-oriented data center service. So what did we learn from this paper? So the first of all is the details make a difference. So when we discuss about the memory cache GPU data structure, we mentioned that set request ordering is very important. So if the author did not think it thoroughly before the implementation, it will cause some problem. So for example, if the set request first update the GPU hash table, then allocate the item data in the CPU memory. So considering the following scenario, the set request immediately followed by a get request, and it will cause some errors. So the second that we have learned from this paper is we need a specific solution for a specific problem. So we have mentioned that the author modified the baseline memory cached implementation. Although the traditional baseline can resolve the problems of collision, however, the design is poor fit for GPU architecture. So we cannot just copy others' successful solution without examine the detailed implementation of the design because it might contradict with what we are going to achieve. So in this paper, the traditional implementation of memory cached um, can degrade efficiency. That's in contradiction with what we are going to achieve. Okay, so much for our presentation, and thank you for your listening.